chemicals from common salt. Okay, chemicals from common salt. Here common salts are produced by a neutralization reaction takes place when acid is reaction with base. Okay, when acid reacts with base, in that time salts are produced. In that there are number of salts are there, but mainly we consider sodium chloride. Okay, sodium chloride, its formula, chemical formula is NaCl. Here NaCl is also famously known as common salt or table salt. Okay, NaCl is commonly or famously known as common salt or table salt. It is used in the preparation of food and it increase the taste of food, or it enhances the taste of food. Okay, so sodium chloride is very important among remaining all compounds of the salts. Okay, in that rock salt, what is mean by rock salts means rock salt. Okay, here the number of salts are dissolved in oceans, okay, which are observed. Okay, the deposits of salts are turns into brown due to their impurities, which are called rock salts. Okay, once again, what is mean by rock salt means here the number of deposits of salts in the bottom of the oceans, which are often turns into in brown color due to their impurities are present inside them. So that's why it will be turns into brown color, which are called rock salt. Okay, next sodium hydroxide from common salt. Okay, how we can observe or produce sodium hydroxide from common salt? Here, what is the common salt formula, chemical formula? NaCl. Okay, sodium chloride. When electricity is passed through the sodium chloride solution or brine solution, it will be decomposes and form sodium hydroxide and chlorine hydrogen gas. Okay, here take sodium chloride and add water molecules, okay, and pass the electricity through the sodium chloride or brine solution. In the time it will be decomposes and it will be formed sodium hydroxide and chlorine and hydrogen gas. Okay, see, observe this equation according to law of conservation of mass. Is equation either balanced or not? See, how many chlorines are, how many sodiums are present? 2 sodiums are present. 2, this is a coefficient value. It is applicable to sodium as well as chlorine also. Okay, how many sodiums are there? 2 sodiums. Here also 2 sodiums present. Here how many chlorines are there? 2 chlorines are there. Here also 2 chlorines present. Okay, next how many hydrogens are there? 4 hydrogens are there. 2 2s are 4 hydrogens. Okay, here how many hydrogens? 2 hydrogens here. Here this 2 hydrogens. Okay, this 2 is applicable. This hydrogens, oxygens and sodium. Okay, here 4 hydrogens. Total how many hydrogens are there? 2 2s are 4 hydrogens. 2 hydrogens. Okay, 2 hydrogens. 4 hydrogens are balanced. How many oxygens are there? This 2 is applicable to oxygen also. 2 oxygens are present. Here also 2 oxygens are present. Okay, according to law of conservation of mass, equation is balanced. When we pass the electricity through the sodium chloride or brown solution, it will be decomposes and form sodium hydroxide, chlorine and hydrogen. Okay, now observe the childrens, in this above chemical reaction at cathode and anode, we observe the where different gases are evolved and what are the uses of them. Here at cathode first hydrogen will be formed. Okay, at cathode hydrogen will be formed. Here at anode chlorine is formed. At next sodium hydroxide will be formed. Okay, what are the uses of hydrogen? Means it is used as a fuels. Okay, it is used as a fuels like petrol, diesel. Okay, this hydrogen is used fuel in rockets. Okay, next it is also used as margarine and ammonia for fertilizers. Okay, in fertilizers, in preparation of fertilizers, hydrogen is used. Okay, ammonia in the present it is used as ammonia. Next, chlorine is used to treatment of water and swimming pools, PVC, that means polyvinyl chloride, and disinfects. Okay, that means disinfects means when bacteria, microorganisms are present, when we add chlorine, it will be converts as disinfects. And next to CFC, that means chlorofluorocarbons and pesticides. Okay, pesticides means which are present, chemicals which are present in liquid form. Okay. Next to sodium hydroxide. What are the uses of sodium hydroxide? It is used as degreasing metals. Okay, degreasing metals and soaps and detergents. Okay, we regularly whatever use soaps and detergents, it is made up of sodium hydroxide, and paper making and artificial fibers, that sodium hydroxide is used. When sodium hydroxide and chlorine is used to bleach, it will be formed sodium hydroxide and chlorine, it will bleach the household bleaches and bleaching fabric. It is formed CaOCl2. Next, when hydrogen and chlorine is formed, hydrochloric acid will be formed. It is also used for cleaning steel, ammonium chloride, and medicines and cosmetics. Okay. Next, bleaching powder. Okay. Bleaching powder, already in previous exercise, in previous activity, we observed that how chlorine is produced. Okay. Once again, when electricity is passed through the brine solution, okay, that is sodium chloride. When we pass the electricity through the brine solution, in that time the chlorine gas will be evolved. Okay. By using that chlorine gas, we can passing through the slaked lime. Okay, calcium hydroxide is called slaked lime. When we pass the chlorine gas through the slaked lime, it will be formed CaOCl2, that is nothing but bleaching powder. Okay. Bleaching powder, chemical formula is CaOCl2, chemical name is calcium oxychloride. Once again, calcium oxychloride is known as bleaching powder, and water molecule will be formed in this chemical reaction. Once again, when chlorine is produced in previous activity, that is chlorine will be evolved. Okay, that is when electricity is passed through the brine solution, it will be produced chlorine gas. By using chlorine gas, when it is passed through the slaked lime, it will be produced the bleaching powder and water molecule. Okay. Next, what are the uses of bleaching powder? Very, very important. Listen carefully. Here, what are the uses of bleaching powder means? Bleaching powder is mainly used to bleaching the cotton and linen in textile industry. Okay, to bleach the cotton and linen in textile industry, and to bleaching the wood pulp in paper industry. Okay, and next, bleaching the washed cloths in laundry. Okay, here these three patterns to use bleaching. Okay. Next, it is bleaching powder also is used as oxidizing agent. Okay, oxidizing agent. Next, third one, here bleaching powder is used as disinfecting drinking water to make it free of germs. Okay, make it free of germs. Next, preparation of chloroform. Bleaching powder is useful in the preparation of chloroform. Okay, once again, listen carefully. Bleaching powder. Okay, what is the preparation method to prepare the bleaching powder means? Here the evolved chlorine gas is passing through the slaked lime. In that time, it will be formed bleaching powder and water molecule. What are the uses of bleaching powder means? It is used in the cotton and linen bleaching in textile industry, and bleaching wood pulp in paper industry, and bleaching washed cloths in laundry. And second one, it is also used as oxidizing agent, and next, disinfecting drinking water and make it free of germs. Next, preparation of chloroform. In the preparation of chloroform, bleaching powder is used as a agent. Okay. Next, baking soda. Okay, baking soda chemical formula is NaHCO3. NaHCO3 is called baking soda. Its chemical name is sodium hydrogen carbonate. Okay, sodium hydrogen carbonate or sodium bicarbonate is famously known as baking soda. Here the components we taken sodium chloride, water molecule, carbon dioxide and ammonia. Okay, but the reaction will be takes place between them, among them. Okay, the chemical reaction will be takes place among them and it will be produced ammonium chloride and sodium hydrogen carbonate. Okay, sodium hydrogen carbonate. Here when sodium hydrogen carbonate on treating, it will produce Na2CO3. Okay, sodium carbonate and water molecule, it will be produced. Okay, in this above chemical reaction we get the sodium hydrogen carbonate. Okay, this is the preparation method. Once again, when we add sodium chloride, water molecule, carbon dioxide and ammonia, the reaction will be takes place among them and it will be produced ammonium chloride and sodium hydrogen carbonate. Okay, in this sodium hydrogen carbonate on treating, it will be formed sodium carbonate and water molecule and carbon dioxide will be formed. Okay, what are the uses of baking soda? Baking soda is used in food for faster cooking. Okay, baking soda is added the preparation of food for faster cooking and it will produce the carbon dioxide. Okay, it will produce the carbon dioxide. So that's why it's bubbling. It will form bubbling in the food materials. So that's why in food materials that are bread and cake. So that's why they are smooth and fluffy. Okay. Here the baking soda, when we add in the preparation of food, in that time it will produce the carbon dioxide. Due to carbon dioxide, it will in that food materials, for example bread and cake, it will be form a bubbles. Okay, due to that the bread or cake will be smooth and fluffy. Okay. Next, what are the uses of baking soda? Okay, here in the main baking powder. Okay, in baking powder mainly contains of baking soda, that is NaHCO3, baking soda and its other components calcium, hydrogen, phosphate and starch contains in this, all three are present in baking powder. Next, it will also produce carbon dioxide. It is also, baking soda also used as ingredient in antacids. Antacid, the word is important. Antacid means it has basic nature. It is neutralize the acidic nature substance. Okay, acidic nature substance. It is slightly has basic nature. Next, it is also used as soda acid in fire extinguishers. Okay. Next, it is also acts as a mild antiseptic. Okay, baking soda is acting as acts as mild antiseptic substance. Okay. Next, washing soda. Okay, washing soda chemical formula Na2CO3. Okay, Na2CO3. Its chemical name is sodium carbonate. Okay, sodium carbonate was famously known as washing soda. Okay, washing soda can be obtained by heating the baking soda. Okay, what is the chemical formula of baking soda? NaHCO3. Okay, NaHCO3. Washing soda, okay, sodium carbonate is obtained by heating the baking soda. Okay, here sodium carbonate when treated with water molecule, it will be formed hydrated sodium carbonate. Okay, hydrated sodium carbonate will be formed. Okay. Next, what are the uses? It is used in the glass, soap, paper industries. Okay, washing soda is mainly used in glass, soap, paper industries. Okay. Next, it is used in the manufacture of sodium compounds such that like borax. Okay. Sodium washing soda is used in the manufacture of sodium compounds that are such as borax. Okay. Next, it is used as cleaning agent for domestic purpose. Okay. Washing soda is used for cleaning agent for domestic purpose. Okay. Once again, next washing soda. Washing soda chemical formula is Na2CO3. Chemical name is sodium carbonate. Okay, sodium carbonate. Washing soda is obtained by heating the baking soda. Okay. Here, when sodium carbonate is treated with water molecule, it will be formed hydrated sodium carbonate. Okay. Next, what are the uses means? It is used in the glass, soap, paper industries. Okay. Next, it is used in manufacturing of sodium compounds like that borax. Okay. Next, it is also used cleaning agent for domestic purpose. Okay. Next, removing water of crystallization. Okay. Removing water of crystallization. Okay. In this experiment, we take a test tube. Okay. This is a test tube. Add few crystals of copper sulphate. Okay. Add few crystals of copper sulphate into the test tube and heat on a burner. Okay. Few minutes. After that, you will observe that small droplets will come outside of the walls. Okay. Outside of the walls. When you apply a continuous heat, it's okay. To the when you heat the test tube on the flame, you observe a small droplets on the test tube. Okay. Here, how this water come from outside means it is observed from the atmosphere. Okay. When we take a dry copper sulphate into the test tube, it has a blue color. Okay. It has blue color. But when we heated this test tube, the blue color will be reappears. Okay. This blue color will be disappear. Okay. Blue color will be disappear. After that, when we add 1 or 2 drops of water molecule to the copper sulphate, it will be blue color will be reappear. That means here dry. This copper sulphate crystals are seems to be dry, but internally it has water molecule. When we add heat energy to the test tube, in that time it will be losing the hydrate molecule, water molecule, and it will be color will be changing into colorless. Blue color will be converted into colorless. Okay. That means we observe here when a molecule is present in a molecule, water molecule is present in a constant ratio. Okay. That is copper sulphate has 5 H2O molecules. Okay. In 1 unit of copper sulphate has 5 moles of water molecule constantly. Okay. Once again, listen carefully. Removing water of crystallization means here take a test tube. Okay. Take a test tube and add few grams of copper sulphate into the test tube. Actually, copper sulphate has blue color. Okay. When we add continuous energy to the test tube, you observe that small droplets of water on the walls of the test tube. Okay. And the blue color of the copper sulphate will be disappear. Means it will be losing water molecules from their compound. So that's why it will be turns into colorless. When we add once again 1 or 2, 3 drops of the water to the copper sulphate, the blue color will be reappears. That means every copper sulphate chemical unit of copper sulphate has a particular amount of water inside it. So that's why water molecule present in its chemical formula. Next, plaster of Paris, very important, dear students, listen carefully. Plaster of Paris, okay, its chemical formula is CaSO4 of H2O. CaSO4 of H2O. Chemical name is calcium sulphate hemihydrate. Calcium sulphate hemihydrate is famously known as plaster of Paris. what is the preparation method? Okay, see, on careful heating of gypsum, okay, on careful heating of gypsum into 373 kelvins, okay, into 373 kelvins temperature, at 373 kelvins temperature, we get the at the preparation of plaster of Paris is when we heat carefully heating of gypsum, that is CaSO4 2H2O. Gypsum at 373 kelvins, it will be lost water molecule and it will be formed as a CaSO4 of H2O, calcium sulfate hemihydrate. It is famously known as plaster of Paris. Okay, when plaster of Paris or calcium sulfate hemihydrate, that is also called as p.o.p. Okay, when we add one and a half water molecule, it will be converted into gypsum. Okay, this is used to doctors. This what are the uses of plaster of Paris means? It is mainly used doctors to the fractured bones to set right position. Okay, doctors are used plaster of Paris mostly to fractured bones to set the right positions, and p.o.p. also used in the designs in buildings, as well as p.o.p. also nowadays are mostly using to prepare the Ganesh ideals. Okay, and how this here one of the question is important in this, how half water molecule will be existed. Okay, how half water molecule will be existed means there is no half water molecule in the world. Okay, in our surroundings it does not exist, but how we can write here means here 2 moles of formula unity of calcium sulfate. Okay, 2 moles of calcium sulfate will share 1 molecule of water. Okay, in that time each calcium sulfate molecule will get after half water molecule. Okay, this is plaster of Paris.